Hello and welcome to another Advent of Code video. In this one we're doing day 18, which is a series of math equations. Let's jump into it. Okay, so I'm not actually going to split up the parsing and execution for this one either. But this is what some of the problems look like. It's just a math equation and they have three operators. There's addition, multiplication, and braces. However, the math in this world is a little bit different in that the operator precedence will change. For part one, all of the operators are going to have the same precedence, so there's no PEMDAS here. It's just left to right execution. I guess except for parentheses. Parentheses will still have higher things. And for part one, what we're doing is we are summing all of the equations. We're also doing that for part two, I guess. But in part two, the operator precedence changes and plus binds higher than star. So all of the additions should happen first. Wait, is it additions first? Or yeah, additions first. And for this problem, I thought a little bit outside the box. I'm going to show you my outside the box solution. I'm going to show someone else's outside the box solution, which is even more clever. But yeah, let's jump into it. Okay, so for this one, we're going to be summing over a list of lines. So I'm just going to put in that sort of boilerplate code first for line in s.splitlines. However, all of the examples that we're playing with today, they're just one single line. Return total. So this is kind of the structure that we're going to use today. I used regular expressions to solve this problem. I know we were thinking like, oh no, regexes. But I used them to just do the precedence stuff. So the way that I thought about this problem is to pull out the parenthesized portions and compute those first and then stick them back in. And you can do that by making a regular expression that matches a parenthesized region. So we do parens equals re.compile, let's see, a literal parenthesis, and then a character that is neither parenthesis repeated, and then another literal parenthesis. And we want to capture this inner group so that we can operate on it. I think that's the right regex. But basically what I did is I did a replacement that took this parenthesis and replaced out any of the unparenthesized regions until there were none left. So in this case, what it would like for this problem here, it would replace out this one. It wouldn't replace out this one fully because we say that there's no parentheses allowed in between, but it would do this inner one, and then it would do this one, and then finally it would be a normal equation, and we'd evaluate that. So what I did here is while parens dot search parens.search line, I did parens.sub, and the cool thing about regular expressions in Python is the substitution can actually be a function. So this will be parens sub callback, and what I did in this callback, parens sub cb, which receives the match object from that regex, and we have to return a string from typing import match. And what we can do in this is we can evaluate the inner part of this expression. So that's what I did. I did return compute value match 0, and we gotta define this function def compute value, which takes a string and returns an integer. So this is kind of our we have no parentheses left, so we can just do the raw computation here. And of course, since this returns an int, we need to stringify this in our regular expression callback. And that just leaves us our compute value function. So for this, what I did is I got our parts equals s.split. So this will split on white space. So in this case, you would get 5 and a plus and a 6. And the way I thought about this problem is you kind of have one value and then you accumulate all of the operators after it in two-part chunks. So I did value equals int parts 0, and then I equals 1, while I is less than the length of parts. Op equals parts I, and then n equals int parts I plus 1. So I'm basically grabbing this as my operator, and then this is my number here by doing offsets here. And then we do, let's see, if the operator is a star, then we do value times equals n. Otherwise, if the operator is a plus, and we do value plus equals n. And I just did this defensively, raise assertion error with what value op n, in case there's some operator that wasn't supported. But these were the only two that were mentioned there. And then finally, after we do that, we need to increase n by 2. That way we're taking chunks of 2 out of this parts thing here. And then finally, when we're done, we can return the value at the end. And I think that implements part 1. Note here that, this will continually... Oh, I didn't actually... I gotta do this down here too. So once we've removed all the parentheses, we still need to do one more pass with compute value. Total plus equals compute value line. Oh, and of course we need to reassign line here. So what this will do here, this loop here will continually replace out the parentheses and compute those inner parts. And then finally we'll be left with just an expression that has no parts in it, and we'll be able to do that. So what I'm going to do here is I'm actually going to print so I can show you kind of how the expression part breaks down. So we'll put that in there, and I'm going to print line every time we get reduced down here, and we'll print line up here as well. Print line. So every time we remove a portion with parentheses, we'll print out the line there. And if we run part 1, invalid int for literal... Oh, I was supposed to use match 1. Sorry. Match 1 is my actual capture group. Match 0 is the entire match here. Cool. So now we can see from these problems. This one required no simplifications. It had no parentheses, so it just got evaluated just normally. You can see we got the expected value there. For the second one, there is one group of parentheses, and so you can see we took this group of parentheses and evaluated that and replaced it with 20. And then finally, we just straight evaluated across. For the second one, we had to do several simplifications. So the first round simplification replaced this group and this group with 6 and 11. And then there's still one more parenthesis group, so we replace that with 44. And then finally, we evaluate the whole thing. So that was how I did part 1. Part 2 is very similar, except for part 2, we suddenly have a higher operator precedence for plus. So let's copy part 1 to part 2.py. And I actually abused the exact same trick. However, instead of, we still have to do parentheses first down here, but we're also going to do addition first up here. So what I did is I eliminated all divisions in a similar way. So I did div equal, or sorry, not divisions, additions. Add equals re.compile, and we have some digit that we're going to capture. We have an addition sign, and then we have more digits that we capture. And we're going to basically follow the same pattern as we did down here. So while while add.search s equals add.sub, add callback, or add sub callback, sure, and s. And so we define our add sub cb here, which takes a match stir, and returns a stir. And for this one, it's pretty easy. We only have to deal with addition here. So we can just do return int match 1 plus int match 2. And, this is our first match group. This is our second match group. And then we have to convert this back to a string so that the types match here. So I basically, let's actually print this in here so that we can see how this reduces down as well. Print f s, so that way we can see this inner part get evaluated down. And if we run part 2 now, let's see. So for part 1, we have to do this inner expression. We need to replace out the addition. So 1 plus 2 becomes 3, and 5 plus 6 becomes 11. And then finally we have 21 times 11, or 231. Similar for this one. I guess in this one we do the parentheses first. So we're doing 4 times 5, that becomes 20. Then we do our addition, so it becomes 23. And then finally we get 46 there, which is what we expect for part 2. And the third one is actually pretty uninteresting because it actually doesn't change. But for the third one, we do 5 plus 6 and 2 times 3 first. So 2 times 3, 5 plus 6, and then 11. What are you, 11? Where did you come from, 11? Oh, I guess because this is an addition, so it simplified this down to 11. Okay, that makes sense. And then we had 4 times 11, because that's a parenthesized group, and that'll get us 44, and then, you know, we just do additions straight across. But yeah, that's how I implemented this problem. It works. It's a little bit hacky, but I thought it was a pretty cool solution. Algorithm efficiency here. I mean, we do parse the string a whole bunch of times, so, you know, it's potentially more work than it needs to be. I don't really know what the algorithm efficiency here is. We'll skip that. But now I want to show you another solution that was brought up in my Twitch stream. And the person, if you want to check out their GitHub, there you go. But this solution abuses eval, which is beautiful. So they define a class called myNumber, and they start by replacing all of their numbers in their code with this special myNumber class, which constructs itself with the actual value. For part 1, they replace all multiplication with subtraction. That way, addition and subtraction have the same operator precedence, and so they'll still be evaluated left to right. And parentheses, of course, will be evaluated in whatever order they want. Then they call eval on this, and note here that we're doing subtraction, and so they override subtraction to do multiplication. So you subtract 2 numbers, and it actually multiplies them. So this is how you keep the same operator still doing the same thing. And then for part 2, they took addition and turned it into multiplication, and for multiplication, it does addition. So now you have a subtraction doing addition, subtraction doing multiplication, and addition doing multiplication, which does addition. Anyway, pretty mind-blowing, but kind of cool that you can do this just with eval. But anyway, that's day 18. Hopefully this was cool. I'll see you again for day 19.